Okay, when we talk about volume, it's different than perimeter, which remember we talked about is the measurement, like a straight length of the outside of a shape. We talked about our garden and the fence. Area, we talked about being sort of inside the fence zone in meters squared. So if we were going to put lawn down, how much lawn we would need. Now we're talking about volume, and this is more of a 3D measurement. So like the length or perimeter is one-dimensional, just a line. Area is two-dimensional, for example, which is why we see something like the units being meters squared, two-dimensional, or centimeters squared. Now we're talking about volume, and this is three-dimensional. So I've put some pictures here of different examples of what you can think of in terms of volume. Up in the corner here, we have liquid volume. So how much liquid you can fit into a different container. You can see this has 3 cups or something like that. When we think of a suitcase, how many clothes you can fit in there. This picture here of this box is beautiful because this is referring to the formula we use for how we find volume. This is a really nice visual here with the cubes inside this box shape. How many cubes can we fit in is telling us our volume. And down here you can see an activity that we might have done in class where you create a box type structure and then we measure the volume by literally putting in these sort of centimeters cubed. So rather than saying centimeters squared or centimeters to the little 2, because it's two-dimensional like area, now we're talking 3D cubes. The little 3 also is said cubed. So you can see there's literally, I would guess, something like maybe there's 6 cubes on the top and maybe 3 levels of that. So 3 times 6, maybe there's 18 cubes in there. And sometimes you can see something else that's 18 cubes that's a different shape volume. But we're just talking volume means how much you can fit inside a certain shape, 3D shape. So these examples are from the first practice task you'll be doing on Excel. This first example is particularly visual and obvious. When we talk about the volume, we're talking about cubic units. So how many cubic units are in this shape? We can count them simply. 1, 2, 3, 4. So all we have to write is 4. This next one, what makes it slightly trickier is we can't see the ones on the bottom layer on this side, but we can assume they're there. So we can count it by going, okay, there's 1, 2, 3, 4 in this sort of layer or slice of the shape perhaps. So another 4 here, so that makes 8, then another 4, 12, and then another 4, 16. I could also have done that by counting, okay, 1, 2, 3, 4, 5, 6, 7, 8 in this sort of side slice or layer. So there must be another 8 over there, so that's 16 in total. These next 2 examples are slightly trickier in that the shapes are a little more complex, but it's still the same concept. So looking for the volume, how many cubic units are there here? This one I don't think is too hard. There's 1, 2, 3 in this layer. We can't see that one hidden back there, but we can assume there's 3 in that layer as well. So 6 in total. This one down here is definitely a bit more complex. I think I'm going to try and count a layer at a time, working from the bottom to the top. So there's 1, 2, 3, 4, 5 in this line. That might be easier for me to sort of write it down at a time. I can't see the 2 that are kind of hiding at the bottom back there, but I know there's 5 in that line. So then there's 1, 2, 3 in this line here. And then only 1, 2 in this little line here. And then 1 there. So that bottom layer, 5 plus 3 is 8, plus 2 is 10, plus 1 is 11. So I'm going to remind myself the bottom has 11. Now this second layer is a little easier to count. 1, 2, the hidden one back there, 3, 4, 5. 5 for that second layer. And then obviously just 3 on top. So then I can add that all together. 11 plus 5 is 16, plus 3 is 19. Okay, in this next example, we're stepping it up a little bit because we can't physically just count them. I mean, it says 7 by 7 by 7, so if we really wanted to, we could stand there and like draw all these lines and figure out how many cubes, but it would actually, I think, take longer than if we just used the formula itself. To make it really visual, I'm gonna hop back to this example we looked at earlier where we just counted up the individual units, and we're gonna use the formula to solve this one. So volume equals length times width times height. So the length of this we could say is 4 units from there to there. 1, 2, 3, 4. We could say the width is 2. So we can count that 1, 2. And then the height is obviously 2 as well. 1, 2. So if we plug these numbers into our formula, length 4 times width 2. Don't get hung up on which is the length and the width, because remember 4 times 2 is the same as saying 2 times 4, and our height is 2. So let's work using the order of operations, work from left to right. 4 times 2 is 8 times 2, 8 times 2 is 16. So when we did this earlier, we also said it was 16. Now we've done it in what's kind of a faster way, especially if the shape is bigger. So now we use this formula to solve the question, the example we have above here. So length, this is really straightforward because they're all the same. 7 centimeters times 7 centimeters times 7 centimeters. Notice we have centimeters 3 times now. This will be important in a moment. 7 times 7 is 49. So I'm gonna actually, remember centimeters times centimeters makes centimeters squared. So we have 2 times 7 centimeters. And then 7 times 49, I'm gonna have to do down here, times 7. 9 times 7, 63, 3 down, 6 up. 4 times 7, 28, plus the 6 is 34. So equals 343. And so this is different, but we have 2 there, and really there's an imaginary invisible 1 there. So centimeters squared times centimeters, 2 plus 1, we now have centimeters cubed. And it makes sense because we're literally talking about how many of these tiny little centimeter big cubes we could fit into this shape. And we could fit 343 cubed centimeters or centimeters cubes in there. Another example with this formula. So let's say, remember it doesn't really matter what the length or the width is. I'm gonna say the length is 2 millimeters just because it's sort of first in the thing there. I'm gonna say the width is 3 millimeters. Whoops. And my height is 8 millimeters. So now I'm solving. 2 millimeters times 3 millimeters is 6 millimeters squared times 8 millimeters. And 6 times 8 is 48. Now I have the millimeters cubed because there's a 2 there and the invisible 1 there. In this last example, it's a little bit tricky because they're getting you again to use that algebraic thinking to find the missing variable d, so what we can consider our length. We know already the volume of this rectangular prism is 48 cubic centimeters or centimeters cubed, so we need to find the value of that. So let's fill in what we have. Our volume is 48 centimeters cubed equals d times 2 centimeters times 8 centimeters. Now, you could, if you're good with numbers, you might be able to just think, what times, and I know that 2 times 8 is 16, so what times, and I'm going to change that to centimeters squared now, what times 16 equals 48? In my mind, I can figure out that's 3. I can check it down here, 3 centimeters, sorry. 3 times 6 is 18, 8 down, 1 up. 1 times 3 is 3, plus 1 is 4. So I already have my answer. It's going to be 3 centimeters. But I'm going to show you how you would figure it out algebraically. We'd want to work to get the d isolated by itself. So the first thing I'm going to do is take away either the 2 or the 8. I'll start with the 8. Opposite to times 8 is obviously divided by 8 centimeters. So divided by 8 centimeters on that side, I have to do on this side, divided by 8 centimeters. The times and the divide cancel each other out. So now over here, I'm thinking what's 48 divided by 8? It's 6. So I write in 6, and notice because we're opposite multiplication, we're dividing. We're going sort of centimeters cubed. 3 minus the invisible 1, we're now talking, okay, down to centimeters squared, equals d times 2 centimeters. Okay, I want to get rid of that 2 centimeters. Times 2, opposite to times 2 is divided by 2 centimeters. Divided by 2 centimeters. Cancels out, cancels out. Thinking, okay, 6 divided by 2, obviously 3. Again, with the unit, we're going from the 2 minus the invisible 1. This is now just 3 centimeters equals d, which is what we said before, but I just wanted to show you the actual steps you would use. Okay, good luck on the task.